Hello everyone. Today let's solve today's Leetcode daily find missing observations. So what do we have to do here? You have observation n plus m on a six-sided dice. So we can choose numbers from 1 to 6, which each face numbered from okay, and observations went missing. We have the average. We have m rows here. We have the average of all the rows, n plus m, and we have how many rows are missing. Now we have to find the new. Now we have to find the left. Now we have to find the rows left out. Okay, let's try this. So we have. So we have m rows. Let's define that first. M equals len rows. We have n, which is how many that went missing, and we have the mean of them all. So the mean is all of the m rows. So let's do some math here. We're gonna say that our mean is equal to, we have all our rows, and then we have two more rows, and then divided by n plus m. So we have the sum of rows, plus our the sum of n rows, divided by n plus m. So what we can do here to get sum of n rows is we can do m times n plus m, and then subtract sum of the m rows to get the sum of the n rows. And we can start with that and then try to make. So we can say sum n, and we'll say n sum is equal to mean times n plus m minus sum of rows. Now we have the leftover sum we need. We need the sum to be over how many ever n there are. So let's say let's check our conditions first. So if it's not possible, then we return an empty list. Meaning, so we have our valid numbers from 1 to 6. So if 1 times n, if basically n is greater than n sum, or we have 6 times n is less than n sum, then we return that this is invalid. Because if we have more n's than the sum, so if we can only choose, the lowest we can choose is 1. We don't have enough, we can't put enough ones to satisfy this. And then if we have 6, if we choose 6 times n, so we max out our possibilities. We choose 6 for each n, and that's still less than what we need, and we know this is invalid. So we've taken care of this case. Now what do we have to do? We have our n sum and we have n. So we need to take the n sum given our n and devise our result array from this. And we know this is going to be valid. So n sum divided by n. If we say we have an uneven sum, say we have something like 11 and we have to split it up between 3. So our n equals 3 and our n sum is equal to, what happened to my cursor? Well, 11. Now what can we do if we do 11 divided by 3, we get 3 remainder 2. So we can have 3, 3, 3, and then we need to distribute 2's. Now we need to distribute 2 along this. So I could technically okay, so let's calculate the remainder is equal to n sum mod n, and our value is equal to n sum, and we do integer division with n, and then we do 4 in range n. We're going to do let's say temp is equal if remainder is greater than 0, then we'll set temp is equal to val. If remainder is greater than 0, then we shall do temp plus equal to 1 and remainder minus equal 1, and then we'll do res dot append our temp. And now let's return our result array. Let's see if that works. Okay, seems to work for these cases. I added another case. What's the max? Can I 10 to the 5? Hopefully it works. Okay, and that seems to work. That was the max, mean. No, it can't be that. Alright, let's try to submit this. And it works. So I hope everyone understood what I did. So basically, I just took our remaining sum for the ends and then divided it by n. This is the base factor of what each number or what each n gets, basically. Each one of the n remaining gets. And then I know I have 2 left over, or I have whatever amount left over from performing my remainder. So these still need to be distributed over the ends. And we know this is possible because we've already checked these constraints. We've already checked the constraints. And then we end up with this remainder. We apply an extra 1 to each of them as we still have a remainder, and then yeah, that should work. So I hope this made sense, and thank you for watching.